Hi, welcome. This is Vikram Madhuskar, and this is my main demo for the Big Data Analytics final project. The topic of my project is neural networks for algorithmic trading, and I'm going to walk through what I try to do and what this project is about. So here is a problem statement. Now, you would be aware that financial markets are very competitive in terms of lots of hedge funds, investment companies competing with each other to maximize the returns for their funds. And there is constant search for new ideas, search for new techniques, search for anything that gives them a higher return than what the other competitors are getting. And in this search, the way the market has evolved over the last, I would say 10 to 15 years, is that the trading as a process has become very, um, computational, very quantitative, and now, for the past, few years, a few years, it has become very automated. Now, algorithmic trading is a kind of a automated trading that basically utilizes some kind of rules-based buying and selling of say stocks or any of the financial instruments in the marketplace. The idea is to minimize the human intervention because the theory is that humans have some biases, and those biases interfere with the optimal decision making for the investment process. So algorithmic trading so far has been more focused on extremely high speed execution of trades. So you would have thousands of trades getting sent out on a millisecond basis, wherein the fastest to execute was the winner of this strategy. Over the years, as more and more hedge funds and investment companies acquired the technology to execute very high speed trades, there has been a diminishing returns on this strategy. Now, the this continuous search for new approaches brought to their attention the potential of using machine learning and big data analytics to generate superior returns. So basically, idea is to analyze new forms of data in new ways and try to generate superior alpha. Alpha is basically the extra return over the market that a fund can generate. All right. So this exploration of machine learning then further led to exploration of deep learning techniques, deep neural networks as the suitable or more optimal model to kind of predict stock prices. Within deep learning, RNNs and especially LSTMs, which are a type of RNNs, were found to be more suitable for handling time series based data. And financial markets, generate financial time series. So the LSTMs are now, the kind of, the favored, you know, neural network types. So my project, I have tried to implement a stock, prediction model using LSTM, and I have used the freely available data, market data from Yahoo Finance, and I tried to model the prices of IBM. Uh, and the date range that I have taken for the stock prices is basically the daily closing prices starting from 1962 till date. So And the technology platform I am using is uh, basically Keras libraries with a TensorFlow backend, and I have used a common laptop with a Pentium dual-core processor running a Windows 10. Additionally, I have used some popular Python libraries as listed in my documentation. So let me describe quickly the technology I'm using. So TensorFlow 1.4. So TensorFlow is now we all are aware that in our class that it's the platform of choice for implementing neural networks at the moment, and it's a library that allows you to build elaborate neural networks, and you have a CPU version as well as GPU version. You could run it on desktops or mobile devices using a single API. And it offers APIs in Python and other languages, and I have used the Python API. In addition to TensorFlow, I have also used Keras, which is a high-level, NN API written in Python, and which sits on top of TensorFlow. And basically, the entire idea of Keras is to basically make designing a neural network model on TensorFlow much easier. So you have much lesser amount of coding required. It's a very modular, stackable kind of a you know process that Keras follows. So basically, you are able to quickly get up and running with the kind of NN model. NN stands for neural network, so I'm gonna say that refer to NN throughout my presentation. So NN models, and you could, as I said, get quickly up and running using Keras. And regarding the Python, so I have used the Anaconda 3 distribution of Python. Uh, this is, the most popular Python distribution or the package, uh, you know, uh, especially for those who are focused on data science. Python 3.6 is the latest version of Python that I have been using. And finally, hardware, as I said, is a simple Lenovo laptop with a Intel dual-core processor with 8 MB RAM and Windows 10 operating system. So the data I'm using is free data available from Yahoo Finance. So you could go to Yahoo Finance and download, daily closing prices for a lot of, all the securities that are listed on various stock exchanges like NYSE, NASDAQ, and so on. And so Panda, there's a data reader available for Panda. It's called as Pandas data reader dot data, which allows you to pull data directly from online sources instead of having to first download the CSV and then basically read it. It makes basically the entire execution more akin to something that you'd like to implement on production systems. So in because you would have streaming data, market data coming in every day, you would need a capability to keep reading the original source of data on a real time basis. And this kind of is a direction, it's a step in that direction. It's not real time, but it's a bridge that allows you to directly connect with the source. So this Pandas data reader is also available for lots of other online sources of financial data. So you could use it for Google Finance, Enigma, Quandl, the St. Louis Fed, Kenneth French Library, and so on. So basically, anybody who wants to play around with financial data, could use Pandas data reader. So description of data, it's a classic time series data wherein you have, numericals for, depicting the open, high, low, and close prices. And then there is a couple of additional fields, adjustment close. So adjustments are done for stock splits and also for dividends. So they basically reflect in the closing prices. And then there is data for column. A column for volume, and then the date. So we are going to focus only on the closing prices for this demo. Here is the chart that you could see, historical price chart for IBM starting from 1962 to the current date. So the steps, let me quickly walk through the steps that were involved. So I installed TensorFlow, then I installed Keras on top of TensorFlow. Then I installed a few libraries on TensorFlow. So the one of these was the Pandas data reader. The second was Beautiful Soup 4. So this Beautiful Soup 4 basically allows you to pull XML data and basically allows you to be more creative with the kind of data you're pulling and how you're presenting. So this is the heart of the project, the steps, the key steps for how this project was implemented. So step one is I pulled data directly from Yahoo and load it into a data frame. Step two is normalize data. So normalize meaning here, and I'll take you to that slide in a moment. Step three is split the normalized data into training data and testing data. Step four is build a model. So this is the LSTM model that I'll be building. Step five is train the model. So we'll pass our data, the training data through this model. Step six is predict prices. And final step seven is basically plot the predicted prices versus actuals and see how your model performed. What is the gap between what the actual prices were and what you predicted with your model? So this is how the original data pulled from Yahoo using Pandas data frame looks like. So this is the normalization part. So basically, this is a kind of N is the window of price changes, and P is a is the raw list of adjusted daily return prices. So this is what I mean. So N1 is basically, simply put, what is the incremental decrease or increase in the price. So you have PI divided by PO minus 1, right? So if basically your stock was 110 today and yesterday it was 100, so the gain is 110 by 100 minus 1, so basically 10%. Uh, Denormalization is basically when you want to read the results, you make it more readable. So you apply that to the price to get the actual closing price or the return of how much your investment turned out to be. And then there is I have used a custom function implemented for this for the called as data underscore processing dot py. So this function performs the normalization. So this is how the normalized data looks like. So you have normalized high, low, open, close, and so on. This is how the data looks like in terms of the plot, the normalized data. So the next step is then you split the normalized data into training data and test data. The prediction time, I'm predicting on a daily basis, so it's 1 day. The test data size is 450 days. The unroll length is 50 days. So this is 50 days is how it basically rolls. So 50 days at a time. It's just a kind of a moving, sequence. Then we have test data cut, which is basically the test data size plus the unroll length plus 1 day. So this is how basically, it keeps on cutting. Okay, so the next step, build the LSTM model. So here, the Keras library, as I had mentioned, allows you to easily build the model, by adding layer, uh, you know, in a stackable fashion. Meaning, I mean, you could simply just assemble them like you assemble a game of Lego. So the pieces that you that put together. There is a dot add method that you typically use in Keras to add the various layers to the model. And then you need to specify the input shape and the or the it's also called as input dim if you are using 2D or 3D layers. Then you also need to specify the batch size. The batch size is the size of the basket of data that would be processed at a time. So this is the code base. I mean the main steps of the code. All right. So the next step is you train the LSTM model that you just created, and for that you basically pass it to you have it go through the data that you split for training. So it will go through your training data and try to extract the features and learn something. So you have, as you can see, the batch size is 3028, the epoch is 100, validation split is 0.05. So these are the parameters of your LSTM model that you could configure and that you could play around. You could decrease or increase them and see how the model performs. So this is the step where you predict the prices on your test data using the model that you just trained, and then you finally plot those results against the actual prices. So as you can see from the plot, I mean this looks a very not a very useful plot at this point, but if you look at it carefully, it does indicate some kind of a generally correct directional prediction, meaning it the model is correctly depicting the direction of the next movement, though in the current form is not able to detect the amount of that movement. So my conclusion based on this is that I mean the model shows promise, and it could be fine-tuned further by fine tuning various elements of this model, the batch sizes, the epochs, the all the various components you just saw. And I think eventually I think I mean you should be able to see much better results than what I am able to produce here. But I think this it's a fairly decent start, and I think I am fairly satisfied that if I were to explore this further, if I were to work more and try lots of different permutations and combinations of the model, I could come up with a fairly decent prediction model. So the final slide is the pros and cons of this project. So based on the plot and based on what I could see in terms of the predicted prices, I as I said, I think it's correctly pointing in the right direction, but it has to be further fine tuned to achieve the precision that would allow you to actually use it. Uh, so with that, the con side is that deep learning models require a lot of data, but I think for the financial markets that should not be a major concern. The what you'd need is much granular data, meaning the not just end of day, but the tick by tick data to be really have a high quality data that you could analyze with deep learning. So that in a nutshell was this project exploring deep learning LSTM model for algo training. So that's all for my demo. Thank you so much. Thank you very much.